Welcome back to another exciting chemistry lesson. In the previous lesson, we learned about titration between strong acid and strong base, and we know how to determine specifically the molarity of acid and volume of acid. How is that equal to the molarity of a base versus a volume of a base? And we also take account in terms of the number of OH and the number of H, right? But that is when we work with the exact number in terms of at equilibrium, okay? Now, in this lesson, we are not going to look at equilibrium, but we are going to look at reaction where there is leftover or excess amount of acid or base. And again, we are talking about strong acid and strong base only. We are not involving any weak base or weak acid in any way. But for that, we have a buffer equation. So that's a completely different story, okay? Which we will cover in the next lesson. Now for this lesson, we are only going to focus on this between strong acid and strong base, which means they completely neutralize each other until there's leftover, if there is any. So at equilibrium, there isn't any leftover, but in this case, we will have it. And what happened in the process when we have an acid and a base react is that we have the acid generate the number of H plus, and the base generate the number of OH. So we have to be very careful in terms of how many OH there are, okay? So that affects everything as well. So first thing first, when we have a chemical reaction, we are going to use up the acid and the base part, right? The H plus and OH to make the water. And when that happens, what we're going to have is that if there are any excess, we either have H plus or OH minus. So if that's the case, we have to determine in terms of mole. So this one is for pH and this one is for pOH. So if there is excess of H plus, we have to calculate pH. And we know that pH plus pOH equal to 14, okay? Because once we find one of them, we can find the other one. And if we have excess OH, we have to find pOH first. So let's tackle one of the most challenging questions out here. First, determine the pH of the solution of a 40 milliliter of this concentration, 0.1 molarity, or again, hydrochloric acid. This is a strong acid right here, and 60 millimeter of 0.1 molarity of KOH. This is a strong base right here. So one thing we have to do, as always, is that we have to compare them in terms of mole. So we have to convert to liter first by dividing by 1,000. You see it right there? See that 30 right there? That means we move 3 decimal places to the left. In this case, right there, because we're trying to make a small number. In this case, we have 0. So 40 milliliter in liter will be 0.040, and then we have a concentration. We multiply that again, time a concentration. But by now you should already know that already. We take the volume, time the concentration, that gave us mole. So time 0.1, and look at that. 0.1 again is 10 to the negative 1. Okay, so we're moving this to the left to make it even smaller when we do the math. And notice how I tricked you. Notice how I show you how to do this without a calculator, because on your AP test you may not have a calculator with you. So we have 0.04 moles of HCl, which is also equal to 0.004 moles of H plus, okay? Now over here, we are going to divide it by 1,000 as well. So again, the 30, we take the decimal, move 3 decimal places to the left. So we now have 0.060 liter, okay? And then we are going to multiply by that molarity. So 0.1, again, that is basically time 10 to the negative 1. So we move this over here one more time. So this gives us 0.006 moles of KOH equal to OH minus. See that? Now we have both of them in mole, so we can compare them. So we know they neutralize each other, right? That means the larger one will have leftover. So all you have to do is take 0.06 minus 0.004, give us 0.002. And what is this leftover? Well, the leftover of OH minus. Now we have the OH minus left over. That means we can find pOH, okay, which is equal to negative log of 0.002. And that will give us our answer. But here, we have a challenging problem. What if this is a multiple choice on your AP Chem test and you don't have a... Now here we have a big problem. What if this is a multiple choice question? Now, but here's a bigger challenge. What if this is a multiple choice and you're not allowed to use a calculator? So we have to convert this. We are not done yet. Remember, this is mole of OH. We have to find internal concentration. So again, molarity is equal to mole divided by volume, right? Where is the volume coming from? Well, the volume is coming from here, okay? So that is equal to 0.002 divided by, well, right here, 0.04 plus 0.06. That gives us 0.002 divided by, well, 0.04 plus 0.06, that gives us 0.1. Now, if we are doing this in our head, if we divide by 0.1, basically that's equal to 0.002 times 10 to the 1. Because this right here basically equal to 10 to negative 1, and when we bring it up, it becomes positive right there. So that's the case, we bring this over here when we multiply, right? So now our answer is 0.02. So that is the concentration of OH. Then finally, we can find a pOH. pOH is equal to negative log of 0.02. Okay? And for now, we're not going to use the calculator. We are just going to do this without the calculator. So we have negative log, but I don't know what's negative log of 0.02. So we have to convert it into this exponent power right there. Right? So it looks like that. 2 times 10 to negative 2. And what we can do is this. We can estimate that 2 times 10 to negative 2. We can ignore this part. And now we have our answer is about 2. So that gives us a pOH. So for pH, of course, is equal to 14 minus 2, give us 12. So again, this is all estimation. But that's what makes it more challenging because we cannot use a calculator on the multiple choice question. Okay? So in a way, we can do this. Now let's try another problem. In this case, what we did was I changed the KOH to BOH2. And what we have here is we have the volume, same volumes, okay? But and the concentration is the same. Okay, but I changed this to BOH2. We'll see how that's going to change the whole entire problem. So here we have 1000, okay, bring that 3 decimal places. So we have 0.040 liter. And we multiply that 0.1, give us, well, bring that over here, one more. So we have 0.004 moles of HCl equal to 0.004 mole of H plus. And of course, you don't have to show this part, so you know that part, okay? Now for this one, we have 1000, okay? So we have 0.06 times 0.1, okay? And now what we have here, of course, I'm going to show you. We have 0.006, but this again, it is BaO2, BaOH, but this is for barium oxide. But this one has 2 OH. So let's go back to our basic stoichiometry. How can I convert this to moles of H? So here's the math behind it. So we have 1 mole of BaOH, okay? And I'm going to show you the shortcut later. And then from there, we have 2 moles of OH minus. See how this cancel out? So what we have here is, well, what's 6 times 2? That's 12, okay? And how many decimal places do we have? 1, 2, 3. So bring 1, 2, 3. There you go. See that? The basic math. But it makes the whole entire problem more complicated if we don't have access to the calculator. So now, one best way to do this is that if all you have to do is just multiply by whatever the number right there. That's a shortcut. Okay? That's pretty much it. The same thing for H over here. If there's 2 there, you just multiply your answer by 2. But this is the full explanation behind it. So in this case, we have 0.012. We have 0.004, so of course this is higher. So what we have here is 0.012 minus 0.004. That gives us what? 0.008, because there you go. This plus that equals to that. So now this is what is mole of OH minus. So again, we cannot solve for pH directly. We have to solve for pOH first. But we had to convert this to molarity by dividing by the volume, right? So what we have here is 0.008 divided by the volume, 0.04 plus 0.06. Again, 0.8 by 0.1, okay? It's the same process. See how this, well, when you do this in your head, it's a lot easier. So times 10 to the negative, well, to the 1. And this right here, bring it up, times 10 to the 1. So what we have here is, bring this back over here, so we have 0.08, okay? And that is the concentration of OH minus. Now we can find the pOH, which in this case, negative log of OA. And right away, we don't know what's negative log of OA. That's too much. That's too complicated. So, but we can reinterpret that into this right here. See how there's 2 decimal places right here? 1, 2. That's how we got that negative 2 right there. So let's do this. We can ignore the 8. In this case, that is about 2. And look at this. So what we have here is pH equal to 14 minus 2, 12. And this right here is your pH. There you go. Isn't that nice? And this right here is your concentration. So as you can see, we can break this down into many parts, and that's what makes this problem so difficult, especially when we are working with so many complicated math, especially log and exponent. But again, practice, and if you have a question, take a picture of your work and put it in the forum, and we will do our best to support you.